In this session, we are going to use the concept of measurements and bound to solve a simple problem. In our case, the dimensions of rectangle PQRS and MNOP is given to us, and we are supposed to find out the largest possible value of the shaded region. Now, shaded region is the region between the rectangle PQRS and MNOP. And in order to find out the largest possible value of the shaded region, we need to find the maximum possible value of PQRS and the minimum possible value of the area of MNOP. For finding out the maximum possible area of PQRS, we will need the upper bounds, and for minimum possible area of MNOP, we will need the lower bound. So in the first case, we are not going to need the lower bounds, and in the second case, we are not going to need the upper bounds. Now let's start working on each of these rectangles. For PQRS, the dimensions are 12 centimeters and 8 centimeters, and for MNOP, it's 8 centimeters and 6 centimeters. Now each of these dimensions are measured correct to the nearest centimeters. So 1 centimeter, I'll divide that by 2 to get 0.5 centimeters. So the upper bound for 12 centimeters will be 12.5 and 8 centimeters will be 8.5. Similarly, lower bound for 8 centimeters will be 7.5, and for 6 centimeters it will be 5.5. Next, I need to find out the area or the maximum area of PQRS, which will be, of course, base times height, but I'm going to use the upper bounds of base and height. So 12.5 times 8.5, and that will be equal to 106.25 centimeters square. Next, minimum area of MNOP, and that will be again base times height, but I'll be using the lower bounds. So 7.5 times 5.5, and that will be equal to 41.25. So the largest possible area of the shaded region, or the maximum area of shaded region, will be the difference of these two. So 106.25 minus 41.25, and that comes out to be 65 centimeters square. That's it. Thank you.